Good day, guys. My name is Babatunde Oluwatosin. Let's have this theory. Let's have this theory. Let P1 be a refinement of P. That is, P is contained in what? P1. Then the lower Riemann stage sum of P is less than or equals to the lower Riemann stage of P1. That is, which is the refinement. And let's prove this first. Then we come back here. Now, prove. If P is contained in this shows that there is an element in P1 that P do not have. Understand? And every element of P is contained in what? In P1. So let's define P to be equals to A equals to X naught, X1. We have SK minus 1, SK dot 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 up to Xn. Now let's also have for P1 now. That is for partition P1. P is contained, that is every element here will be in what? In P1. So let's have this dot up to SK minus 1. Now in between here, let's put an element here whereby P is not containing. Now we have this. So our normal definition for lower sum. Our normal definition for lower sum is from year to n, whereby there is no intervention. Whereby you want to define lower sum by definition. We have LP FG to be equals to summation I equals to 1 to n. We now have small mi delta gxi. This is small m. Now, this is the normal definition, and it's starting from year to year, whereby there is no intervention. Now, but in this case, we are having some points there. You can look at this place. So we have to define the particular lower Riemann stage sum for that point. So let's for partition P1 now. That is, I'm talking of this now. Let's give the small m, that is m star, to be equals to. Now let's define for this region now. From this range to this range, let's define it now. You need to be infimum of what? F of x acting on. It starts from year to year, so it will be sk minus 1 less or equals to x less or equals to x star. We grab it now. Also, we now look for we define the small m for this now. So let's give that one m star to be equals to infimum f of x. It will now be x star less or equals to x less or equals to sk. Do you get it? Now let's define for this region too. For partition P, which is under partition P, right? For partition P, let's give down mk, which is equals to, we have it will be infimum f of x. It will now be sk minus 1 less or equals to x less or equals to sk. Now when we get there, I will explain something here. Let me explain it. If this is less than this, what do you think the infimum will be? The infimum will be what? Sk minus 1. Do you get it? Because you can see that from here, this one is less than this. So, do you get it? Now from here, what will be the infimum of this? Is what? x star, abi, because x star is greater, x star is smaller than this, abi. Look at x star is smaller. Do you get it? Abi, x star is smaller than this, so the infimum will be what? X star. Now come here now. What will be the infimum here? The infimum here will be what? Sk minus 1. So what do you think the function will be acting on? The function will be acting on each of these. Do you get it? Now let's have this now for partition TION, for partition P1 now. Let's have our lower Riemann stage now. So P, F, P1, then G, abi, which is equals to, now let's look at, we have this stuff here. Follow me please, which is P1 equals to, now when we started from x0, x1 until we get to this point, abi, we start introducing at this what stage. So there's an intervention there where I is equals to 1 to k minus 1, because this is where the intervention starts. I equals to 1 to k minus 1, because this is where the intervention starts. So we are going to have mi delta g of xi, abi. Now plus, you can see that when we now get to this place here, we define our m for that point, which is what? You can see the m from sk to x star is what? M. So we define it as m star into brackets, following the normal definition. Once you put m, you are going to look for the change in the what? In this. So we are going to have g of x star minus g of sk minus 1, abi. Now plus, you see that from here again we define our m for it again, because we are going to define the lower sum for each at that spot. So we are going to have what? For this one, we define it as m star star. Then we look for the change abi. Now this is the, then plus, from here now, the next one will be what? K plus 1 to what? To n. So we are going to have summation I equals to k plus 1 to n. Then we have our mi delta g of what? Xi. Now you can see there's an intervention here which we define the lower sum to this point. Then we define from this point, we define, okay, we are using this one. We define the lower sum to this point. Then from this point, we define the lower sum. Then from here, we define another lower sum. Then from here, continuation. So, do you get it? Now, for partition P now, for partition P, whereby we have LPG to be equals to summation I equals to 1. Same thing. You look from here, there's an intervention here, so we stop at what? K minus 1, abi, which will now be what? Mi delta g xi, abi. Now plus, when we now get to this region, look at, from here we get to this region. So we already defined it for partition P now. We already defined it to be what? Mk. What we are doing is we are defining the lower Riemann stage sum at every point. So here now you can see what is the interval for this is what? Sk minus 1 to sk. So we are having g of sk, g of k minus g of sk minus 1. Now plus, now from here now we continue, so that will be summation I equals to k plus 1 to n. Then we have mi delta gxi. So how can you know if something is small? Let's pause here now. Let's pause. How can you know if something is small or if something is lesser than something? Let's assume that we have a now and we have b. If you subtract a minus b and you're having positive number, this shows that a is greater than b, isn't it? But if you do a minus b and you're having negative number, this implies that b is greater than what? A. Do you get it? Do you get it? Do you get it? Just a simple assumption. If A minus B is positive, it shows that A is greater than B. Very correct. But if A minus B is negative, it shows that B. So now we are going to do something now. If you have L P1 Fg minus L P, if we subtract this now and we are having a positive value, it shows that this is greater than this. That is, the lower Riemann state sum of P1 is greater than the lower Riemann state sum of P, which is about what the question given to us. Now, if you subtract this now, look at, we are subtracting this from this. You know this and this we cancel. Abi? Now look, here we also cancel. Abi, because they are the same thing. If you look at it, they are the same thing. So we'll be left with what? We'll be left with M star. We'll be left with M star G of X star minus G of SK minus 1. Abi? Plus, let have it here, plus M star star. Abi? G of, M star star G of SK minus G of X star. Are we? Now when we now come here now, it is minus this. So we have minus MK to be G of SK minus G of SK minus 1. So do you get up to this stage now? So we will move from here now. Now, let's have this. Hopefully you are understanding it. Now look. Here, I want to introduce 0 because if you look, we have our SK here and we have X star here. So, no, we don't have X star. We have this here and we have SK. So we are introducing 0 of X star so we can be able to factorize. Now, what is equals? We have LP1 FG minus LP FG, which is equals to, we have M star. This, I can write this as delta, the whole of this here. Now you have delta G X star. You understand? Because if this one I can write it at the next, this thing, look at delta G is subtracting this, which is correct. So plus, this now will be M star, Abi. I can write this one as delta GXK, Abi. Now look here, this one, I want to introduce 0 now, plus, no, minus, it is minus MK equals to GXK. Now let's introduce 0 here, X star, Abi, plus GX star minus GXK minus 1. Abi, we have this. Now, let's break it down now. Look at, if you bracket it like this now, we are going to have minus MK. I know this one is what? This kind of range here. We already defined it here. Look at, to be what? Delta GS. Look at delta GXK. Do you understand? So look at this. Let's break this also. Let's break it down too. So we are going to have minus MK. Look at where the MK is coming from. MK is multiplying them. MK times this. MK times this. I know this one we already defined it to be what? Look at here. We will have it here and we define it to be what? Delta G X star. Abi? So this one is delta G X star. So for me now we can factorize. Abi? Because if you look at these two, they are having the same thing. So we have M star minus mk because they're having the same thing. So we can have it as delta G x star. Abi? Now look at this and this now. They're having the same thing. So we can say plus m star minus mk. Abi? Delta G x k. Now look at something. This, from here now, we know that m star is equals to what? Xk. Abi? From here, the previous explanation. Now we have our m star star to be equals to what? X star. Abi? From this. And we have our mk to be equals to what? Sk minus 1. Now, the diagram you have. Now, let's have this diagram now. You have our sk minus 1. Abi? We have x star. Abi? This is what we have. Now, we have this expression as we have m star minus mk. And we know that this and this, look at m star and mk, they are equal. So this one is trying to tell us it to be 0. Abi? Now, just an assumption. Look at m star star minus mk. Look at, we know m star star is equals to x star. It's greater than mk, which is this. Abi? M star star, which is what? X star minus what? Xk minus 1. Which will be what? Positive. Abi? And we know that our change in delta G, whatever it may be, it will be what? Positive. It will be positive. These two will also be positive. And do you know why they are positive? Because look at, if you say you subtract this from this now, so far this is greater than this, it will be what? Positive. So that's why they are what? Positive. Now, indirectly, the whole of this expression is what? Positive. Do you get? This is F. The whole of this expression is what? Positive. So we have this, Abi, minus LP FG to be greater than what? Greater than or equals to what? 0. The reason I put equals to, there might be a case whereby all of them will be equal to each other, whereby we are going to have 0. So let's put equals to 0. Now, this implies that LP1 is greater than or equals to LPFG. Do you get it? LP. So we can also write it to be in this form of our question, whereby this one is less. Then we can say LPFG less or equals to LP1 FG. So it's very simple. So you can also try for this, or you wait for my next video. Let me do this. Thank you.